Hello, students. In this video, we will learn about motion. Imagine a book lying still on a table. That book is at rest because its position isn't changing. It stays in the same place relative to the table. Now think about reference points. When you're in a car, the trees and other cars outside are your reference points. They help you understand if you're moving by comparing your position to them. Different reference points can show different stories. For example, if a person walks on a train, they might think they're just walking, but someone outside the train sees them moving forward with the train. The person's motion looks different depending on where you are looking from. Let's talk about distance and displacement. Distance is how much ground you've covered. It's the total length of your path. It's a scalar quantity, meaning it has magnitude but no direction. Imagine driving on a winding road. The distance you traveled is the total length of that road. Displacement, on the other hand, is the shortest straight-line distance from the starting point to the final point. It is a vector quantity, meaning it has both magnitude and direction. If you drove in circles and ended up where you started, your displacement would be zero, even though you traveled a long distance. Now let's explore the types of motion. In uniform motion, an object moves at equal distances in equal times, like a car driving straight at a constant speed. Non-uniform motion is when the object travels unequal distances at equal times, like a roller coaster that speeds up and slows down. Next, we have speed and velocity. Speed tells us how fast something is moving, but it doesn't include direction. Velocity, however, includes both speed and direction. Average speed is the total distance divided by total time, while average velocity is the total displacement divided by total time. Acceleration is how quickly an object's velocity changes. It can be positive, which means speeding up, or negative, which means slowing down. You can calculate acceleration by subtracting the initial velocity from the final velocity and dividing it by the time. For uniform acceleration, the speed increases by the same amount each second, while non-uniform acceleration changes unevenly. Now let's look at graphs. Displacement time graphs show displacement over time. A straight line indicates constant speed, a curve shows changing speed, and a horizontal line means the object is at rest. Velocity time graphs illustrate changes in velocity. An upward slope indicates speeding up, while a downward slope shows slowing down. Acceleration time graphs depict how acceleration changes. A horizontal line represents constant acceleration, and sloping lines indicate increasing or decreasing acceleration. Uniform circular motion happens when an object moves in a circle at a constant speed. Even though the speed is constant, the direction is always changing, which means the velocity is changing too. This requires centripetal acceleration, which points toward the center of the circle. Now remember, motion is everywhere. You can learn more about it every day just by observing the world around you. Now here is a question for you. In a velocity time graph, what does an upward slope represent? Please share your answer in the comments. The complete curriculum for Class 9 is available on our channel. Check out all the links provided in the description below. Please make sure to like, share, and comment for more such videos.